In this second day of section 4.4, we're going to move off of the unit circle. So what we talk about today is not necessarily on the unit circle. So we're going to talk about trig functions for any angle. Now I'm actually going to start with an example here. Let negative 2, 3 be a point on the terminal side of theta. Find your sine, cosine, and tangent of theta. And you actually completed problems like this in Algebra 2, where you were just given an ordered pair and asked to do trig ratios. So you actually already know the definitions for the trig functions of any angles. I'm going to give you a moment with your small groups, kind of chat about it. You don't have a lot of information, right? So it's like, what can you do with the information that I gave you that might allow you to find sine, cosine, and tangent? So brainstorm with your groups. I'm going to be walking around and eavesdropping.
We have a negative 3.
Remember, this is not necessarily on the unit circle.
Right.
So then make 5 years.
Square root of 13.
You don't know what terminal means? Remember, initial side is the positive x-axis, and then terminal side is the
Yeah,
square.
and then,
Plus 3 squares, 90 squares.
What's the terminal side mean?
it's like the end side of it.
So 2 3's on that point and it's going from there down.
To any groups having a difficulty getting started, remember I said there's not a lot of information. Really, the only information you get is an x and a y coordinate. What can you do with x and y coordinates? You've been doing it since Algebra 1. What can you do with a point? Plot it! If you haven't plotted that point yet, I would. And then Emma gave another great hint for sine, cosine, and tangent. Draw a triangle. Plot the point. Find your triangle. See what you can come up with. I like that a lot.
Well, that,
Now I'm going to be real picky about the triangle that you draw.
Yeah, this one's
If you go back to
so
the
then you
y-axis,
just,
you make an hourglass. We want to make.
well, since you know all of the numbers, then you solve for the x.
So don't go back to the y-axis, go back to that.
right. But
So like Maddie's got her unit circle out. You want to draw
Yes.
triangles. They're not going to be those triangles.
It would be the one
Circle.
here.
You draw triangles that look.
That's what I was thinking. Yeah. Oh wait. But it's
So
asking.
if you made
of
4
the-
more triangles like that.
Angle, not the.
I know.
Hourglass.
So we're supposed to be finding
Like that.
this.
Yeah. But you can't do that. It's not.
I want to think you're fine.
Okay, if I plot the point negative 2, 3, that represents a point on the terminal side of my angle. So remember, my initial side must be the positive x-axis. My terminal side is passing through negative 2, 3, and it might extend beyond, but that's a point on the terminal side. And so my angle theta is really this angle over here. But if you think about what we talked about yesterday, we don't do sine, cosine, and tangent with those angles because they don't sit in a right triangle. Yesterday, at the very beginning of class, we talked about reference angles. So we're looking, because this is a terminal side in quadrant 2, we're really looking for our reference angle right over here by the origin, theta prime. And so what you want to do is draw a right triangle with your terminal side and your reference angle. So terminal side, and we want to include the reference angle. We're going to drop down to the x-axis. These triangles that you draw in quadrants 2, 3, and 4, they should be like those triangles when we were building our unit circle. The right angle has to sit on the horizontal axis. So they're going to form butterflies or bow ties. That's the reason why I call them butterflies. I know that's super cheesy, but it's like if you could picture it's a butterfly and not an hourglass, my hope is that you don't draw the wrong triangle. Okay. You're not supposed to draw the triangles back to the y-axis. Draw them back to the x-axis. So now we can label these two sides since we had that ordered pair. As I was walking around, I saw some people label that side 2. And I get that because in geometry we would argue the sides of a triangle can't be negative. But you should have had a conversation last year in Algebra 2. We're looking at this more as like a function of x and y on the coordinate plane. So we are okay if x or y is negative. It's just telling us the direction. So I would label that side -2 and the other side +3. And I heard some groups say next step would be find the hypotenuse. Yeah, find the hypotenuse. We're going to use the Pythagorean theorem to solve for the hypotenuse. Now, I'm going to label the hypotenuse a special letter in these problems. I'm going to call it R. What does R usually stand for? Radius. Okay, and so we are talking about the radius of some circle. All the other triangles that we have done on the unit circle, those all had radius of 1. These circles are going to be larger or maybe smaller than the unit circle, but the idea still works the same way. Like there is some radius, and we could move that point anywhere on that circle, and we could find the trig ratios at those different angles through their reference angles. Okay, but we're focused on this one with this right triangle. So to solve for R, I would do Pythagorean theorem. R squared equals 3 squared plus -2 squared. If either x or y is negative when you square it, it will be a positive. So we're going to get R squared equals, 9 plus 4 is 13. R equals the square root of 13. And now you should be able to answer sine, cosine, and tangent. You know, on the next slide, I'm going to give you a definition here, but we should, just by right triangle trigonometry, if we're looking at theta, which is really theta prime, the sine is opposite over hypotenuse. So 3 over square root 13. And then, of course, we'd have to rationalize. Cosine is -2 over square root 13. Again, we got to rationalize. And the tangent would just be opposite over adjacent, which is 3 over -2. Okay. So make some connections to what you know about trig. One thing that we've mentioned a few times is all students take calculus. Okay, that tells us which trig functions are positive in which quadrants. Because this triangle, this point, -2, 3 is in the second quadrant. That's the quadrant we would label S, which means sine and cosecant are positive. So take a look at your 3 trig ratios. Sine is positive, but cosine and tangent are negative, as they should be in quadrant 2. Okay. Down here for tangent, I just put that negative anywhere. It is really 3 over -2 for opposite over adjacent, but these, I wrote it on the sideboard. Those things are all the same. It doesn't matter where you put the negative. Okay, so I don't get really too bothered by that, and that'll come in handy later as well. I feel like there was something else I was going to mention. Let's talk about,
So we're really finding theta prime.
Yeah, so you can't, like with theta, the standard, the angle in standard position, you can't do right triangle trig with that theta because it's more than 90 degrees. And no right triangle has an angle more than 90 degrees, an obtuse angle. So like if you're in quadrant 2, you're in quadrant 3, or you're in quadrant 4, you'll be working off of theta prime, which is the reference angle. And they have the same, it has the same trig ratios as theta, which is what we defined yesterday. So yeah, you are working off of theta prime, but that's the same as theta essentially. Okay, let's look at it so that on the next slide we can kind of make sense of this. When we did the sine was opposite over hypotenuse, what was opposite? X or Y? Y. And it doesn't matter which quadrant you're in. The X is always going to be adjacent, and the Y is always going to be the one that side that drops down or goes up. So that's always going to be your opposite side. Bless you. Also, one other thing to notice when I solve for R right here, the radius, well, X and Y can be positive or negative to represent direction on the unit or on the coordinate plane. The radius, you're always going to solve for positive. Here, it actually represents the length of the circle. So then you want it to be a positive value. Okay, here's the definition, the general definition for any point x, y. And when we write these down, these should sound familiar to us. So we're going to let theta be an angle in standard position with xy a point on the terminal side. And notice I have a statement for r. R is square root of x squared plus y squared. That is just a result of your Pythagorean theorem. R squared equals x squared plus y squared. For all the triangles and all the quadrants, x and y will be your legs, r will be your hypotenuse. So they're all set up the same way. And because we're going to see this a lot, we just shorten it to r equals the square root of x squared plus y squared. That is not the same as x plus y. So you actually have to do x squared plus y squared, then square root the sum. But we'll see that even in chapter 10. So that doesn't go away all semester. Super helpful. And then I'll put it out here visually. I'm just going to pick a point somewhere on the circle with radius r. And it reaches some point xy. I can always, in any quadrant, draw a right triangle and label the sides x and y. Remember that the right angle will always be at the horizontal axis, so it's going to look like a butterfly rectangle. Or sorry, triangle. Bow tie. And then your angle, that one's not theta prime, that one's just theta. Your angle, even if you're working off of theta prime, the reference angle, in quadrants 2, 3, and 4, it will always be right here around the origin. Okay, so you're always looking from this angle. So that's why y is always opposite, x is always adjacent. So looking at that triangle, we could say the definition for sine is what values? I'm sorry, I can't hear. Y over r, then x over r, and y over x. Of course, for cosecant, secant, and cotangent, you're just going to flip those, r over y, r over x, and x over y. That should seem familiar to you, like you saw that before in Algebra 2. And maybe you were thinking about that back when we did the unit circle. Now, this is a different definition than I gave you when I talked about the unit circle when I did sine t, cosine t, tangent t. Now, the tangent and the cotangent look exactly like y over x and x over y. why is my definition different for the unit circle? Why on the unit circle can I say sine is just y? Because why, Emma? Noah?
The radius is
Because if it was the unit circle, the radius was 1, so y over 1 was always y. I didn't really have to worry about the radius. So remember, if it's not the unit circle, if you don't know that the radius is 1, then you'll have to do y over r. If it is the unit circle, if you know it's happening on the unit circle, then you can use y and x for sine and cosine. Okay, one more example that I want to show you, then I'll have you work through one with your group members. It's just a new way to kind of use all this information. So you're given some information. Cosine of theta is 2/3. Tangent of theta is greater than 0. And I want to know what the cosecant of theta is. So I don't have to do all 6 trig ratios. I just got to find cosecant. The biggest issue that my students have on this type of problem is, in the end, getting the correct sign, positive or negative. So I'm going to walk you through what I think about, and then you're going to try one on your own. Okay, first off, I tackle this cosine of theta. Well, the cosine of theta is 2/3, and from the definitions we just wrote down, cosine is always x over r. This is not 2/3 is not something that I know from the unit circle, so I'm going to assume it's not a theta on the unit circle. The other thing I know about cosine is positive here. Positive 2/3. So if I'm thinking about all students take calculus, cosine is positive in quadrant 1 and quadrant 4. So this means I'm either in quadrant 1 or in quadrant 4. I don't really know which one. At this point, I could draw 2 triangles, and I could come up with 2 different answers for cosecant. One that's positive and one that's negative. But there's another piece of information. I'm also told something about a second trig ratio. I know that the tangent is greater than 0. So if tangent is more than 0, that means tangent is positive. And tangent is positive in quadrant 1 and quadrant 3. And you probably won't write down all the quadrants all the time, but I'm just doing this for example here. What quadrant must I be living in for this problem? It must be in quadrant 1. It's the only one that will work for both. Okay. So now I know I'm in quadrant 1, and I should draw my triangle in quadrant 1. If I'm in quadrant 2, I draw a triangle. Quadrant 3, quadrant 4. But they gotta make the butterfly or the bow tie. And now I can label x and r, so the radius is 3 and x is 2. I'm going to use Pythagorean theorem to solve for y, and I know y should come out to be positive, right? In the picture, y is going up, so it has to be positive. If I had drawn one in quadrant 3, when I solved for y, it would be a negative value. Okay, so I have to think about it on the coordinate plane. So that's what? 9 equals 4 plus y squared. Y squared equals 5. So that must be a positive square root of 5. And then I have all the things I need for cosecant. Okay. Cosecant is the reciprocal to sine. Sine is y over r. This is going to be r over y, which is 3 over square root of 5. And I'll rationalize to get 3 square root of 5 over 5. You can also do a sign check, positive or negative sign, at the end by just like verifying your quadrant. In quadrant 1, where I said I was living, everything should be positive. Double check your final answer. Is it positive? Yes, it is. So I'll give you one to try with your PUD members, and you can kind of break it down and see if you agree to the quadrant, if you can label and find the side that you need, and then if you can find the correct trig ratio. So So try this one. The tangent of theta is -4/7, and the sine of theta is less than 0. So I'll give you some time to work and chat, and I'll check in with you in a little bit. Hey Nate, can you work on this problem for me, please? What quadrant are you in?
4.
Quadrant 4. Tangent and sine are negative in quadrant 4.
You know what I did? I somehow squared this wrong. I'll get back to you.
Yeah, this one. Yeah, I did that.
Yeah.
Okay, because the sign is less than 0, that means it's negative. So you gotta be in quadrant 3 or quadrant 4. But tangent is positive in quadrant 3, so you must be in quadrant 4. You have to be really careful here, like when you have a negative ratio, assign the negative to the correct side of the triangle. So like in the picture in quadrant 4, you're going down. So the y value should be negative and the x value should be positive. What did you guys get for your radius? Square root of 65. Excellent. That's the square root of 49 plus 16, so the square root of 65. So you're just using Pythagorean theorem there. And now we want to do the secant of theta. So the secant of theta is the reciprocal to cosine. Cosine is x over r, so this is r over x. And we're doing the square root of 65 all over 7. And that's our answer. Again, You can double check your sign, positive or negative at the end, by doing all students take calculus. This is in quadrant 4 where we say calculus, which means cosine and its reciprocal secant should be positive. Is that in fact true? Yes, it is, so you got the right sign at the end. Okay, so something to think about. Any questions? Okay. Your homework is on your gold sheet. We've got about 10 minutes left, so I would grab a book and share with your